Hey guys, this is David Piper, also known as TV Man by some folks. I am starting my YouTube channel to kind of build some brand and just get general awareness of my life and what's going on. Uh, so one thing I'm going to start doing is just sharing some helpful information about things that I'm working on. So right now I'm working on what I call Project Saturn, which is a financial AI. So I'm just going to give you guys an overview of that today. Hope you enjoy. So right now I am training Saturn. I just accidentally closed it, so we're gonna train that again, and I can show you guys kind of how this works. Um, so, oh, I guess it's not closed. We're gonna go ahead and close that real quick, and then you can take a look at it. So we've got, let's see. Okay, so it's closed now. So we're gonna go to here. We're in the Saturn directory and we're running train. We've got this command line arg no build, which just tells it to not rebuild the whole project. We just run with this poetry run train command, and I'll show you guys some of the commands later that runs the training portion. We also have a forecast one that will forecast. Currently, this is a multimodal transformer based AI that it's similar to ChatGPT, if you know about that one, I'm sure. Right now, it's taking into account the date. So it does a date. We do a series of partial derivatives, and I can show you guys real quick what that means. So essentially what that is we have, it's like in math where you have partial derivatives. So here's the partial derivative of the price. So we calculate using the price as a feature, in other words, and then we predict the output price. We also have one that takes in the volatility and tries to predict the price. This is a volatility derivative. And then we also have we take in the date and try to predict the price. So this is kind of like, then we combine those two with a fancy combination function. It just takes in some sort of weight. So in this case, we're weighting the price prediction the heaviest. Although I might switch to using this one heavier more. Well, we'll see. We might also start using a weight list just to like see that, because I feel like that is going to be potentially better, because I want this to have a different weight than this one and potentially this one. So we'll see how that goes. Also, I'm going to show you, so this is what's happening. It's currently running on the GPU. It's not using a ton of resources, which is good because I've kind of optimized the performance quite a bit. So it's using 23% of our GPU, 2.3 gigs of GPU memory. So it's not super beefy right now because we've done a lot of optimization. Although I might go crank this stuff up later on. Anyway, we have this partial derivatives that we're combining in the multimodal stocks transformer class. And this is all using PyTorch, by the way. These are all PyTorch neural network layers. This is a stocks transformer, and I'll kind of go through that in a minute. So we've seen the multimodal one, so that combines the stocks transformers together. The stocks transformer combines different stock transformers together. So essentially we have these different models. This is also multimodal. And multimodal just means that it has different modalities or features that are being combined to produce a single result, rather than, or any result really, but in general it's a single result, to do some sort of prediction, rather than just having one. So for example, in ChatGPT, it's not multimodal. It just has text as the input, and it always outputs text. With this, we have price information, we have date, we have the volatility information, plus we also have tickers. We kind of start with tickers. Tickers is like its own little feature here. We also have the time windows, which is acting as a feature. So we've got like many modalities going on here at once, which kind of gives us more accurate results. That's the hope anyway. So by combining them, we get like a more grounded result. We also have, so in this one, we have this loop here that just initializes these guys. We have these modalities here. So we have a ticker price prediction and a time window price prediction. So these again are just these partial derivatives which we combine using the same basic idea here. And I'm probably gonna do some refactoring and maybe move this around because I recently added some. I recently added the multimodal stocks transformer class that's on top of this, so we might do some refactoring to include some of those stuff in there. We have this transpose. So this is our combination. This is our combined features function. This is pretty fascinating. This is our multimodal like workhorse. So it takes in the results, which is just a list of the layered results. So this is a generic as well. This is a brand new Python feature. This generic. This is looks very similar if you're used to TypeScript or C++ or something templates. It's the same idea, or Java generics. They just added it to Python. So we have that, and we call these. We take these results in. We grab each feature and each result. This is a tensor. A list of tuples. So for each feature and result tuple in here, we grab each feature. If it's weighted, then we apply the weight. Otherwise, we apply the inverse of the weight, which is 1 minus the weight divided by the length of the results. So, for example, if it's 95, if the weight is 95, this would be 5%. So we're only going to apply 5% to that result. We just use a regular multiplication operator on this result, which is a tensor multiplication, so it's going to be a scalar multiplication of the matrix, in other words, scaling it down, and then we combine them. We append them to this results list. We then use torch.stack to combine the results across a new dimension. We take that dimension, we transpose it with whatever our transpose is that we passed in, and generally it's 0, 2 for linear. We're swapping the 0 and the second dimension around. If for a convolutional layer, it's going to be a 0 and a 1, swapping those. So that's kind of what we do there. We call the combination layer with the concatenated predictions, and then we transpose it back, so it's in the format that we want. We passed it in. We don't, like, it would be weird if we passed in something and then it came back with all the dimensions swapped around. So, and we squeeze it to get rid of that extra dimension. So this is our combination layer, like, function here. It's just a little hopper function. We also have an activation function, which is torch.abs. That's what I've been using. You could also use ReLU or something else, but I've been using absolute value because it tends to be what I want. I tend to want something that's not non-negative, but I don't want to mess with any of the results here. This is kind of how the workhorse of this is going, and it's pretty simple other than that. Like, it's not simple, but it's straightforward at least. So we have a Y finance integration here. We have some pre-processing that we do. We do this to get this is a feature that I added today where we calculate the true range. It's just a day trading metric that we can use for analyzing stocks. We've got this download ticker data. So this downloads things from Wahoo Finance, which is just YF.download, and then we get a list of tickers and the start date. We have this so that we can diff. We also store things to disk. We load ticker data from disk. So we use the pickle format, joblib.load, and then we give it the directory and the tickers data. There's a lot here going on here, and I'm probably not going to cover all of it today, but I will probably cover it later in future episodes if somebody's interested. I will definitely go through and give you guys more of an overview as time progresses, but I don't want to take up a ton of time today. I just wanted to kind of give you guys an idea of what's going on with this. Anyway, I hope that you guys enjoyed this. I'm going to be doing more videos soon, putting on the channel. So stay tuned for that, and please let me know if you like the content, you don't like the content, what content you would like to see. And yeah, please like and subscribe. Bye.